Nutrition Science Introduction to Lipids. When you think of foods important in the Pacific Northwest, salmon may first come to mind. But to many indigenous people who have made their home along the Pacific coast, a smaller, humbler fish is considered even more vital: the Yulican Smelt. Traditionally, one of the first signs of spring in the region was the migration of the Yulican Smelt into the region's rivers. These thin blue and silver fish spend most of their lives in the cold Pacific Ocean, but when it's time for them to lay their eggs in early spring, they swim up into the rivers of Oregon, Washington, Canada, and Alaska to sow the seeds of their next generation. For indigenous people living in this region, who historically subsisted through long winters on stored and preserved foods, the arrival of the Yulican Smelt would have been a welcome infusion of calories and flavor. Legends describe the small, oily fish saving entire villages from starvation. It's also translated as savior fish or salvation fish. Beyond the timing of its late winter arrival, what makes the Yulican Smelt so valuable is its high lipid content. It's so oily that dried Yulican will ignite and burn like a candle, and nutritionally, it's a dense source of calories. Remember, fat contains 9 kilocalories per gram compared to just 4 for carbohydrate and protein. It's also a good source of fat-soluble vitamins, especially vitamin A, and high in omega-3 fatty acids. William Clark of the Lewis and Clark expedition, after tasting smelt from the Columbia River in 1805, wrote, "They are so fat they require no additional sauce, and I think them superior to any fish I ever tasted, even more delicate and luscious than the white fish of the lakes, which have heretofore formed my standard of excellence among the fishes." Clark may have been the first person of European descent to document the smelt, but it had long been valued by indigenous people. These traditional uses of the Yulican Smelt continue on a smaller scale, but since the 1990s, the Yulican population has collapsed. Researchers say its biggest threat is climate change, and smelt have been classified as a threatened species under the Endangered Species Act. The historical significance of the Yulican remind us of how vital these molecules are to our survival. In today's world, when we can obtain a day's worth of calories and more than enough fat with just a quick trip through a fast food drive-thru, it's easy to forget the biological and cultural importance of lipids. Nutrition Science, the functions of fats. Fats serve useful functions in both the body and the diet. In the body, fat functions as an important depot for energy storage, offers insulation and protection, and plays important roles in regulating and signaling. Large amounts of dietary fat are not required to meet these functions because most fat molecules can be synthesized by the body from other organic molecules like carbohydrate and protein, with the exception of 2 essential fatty acids. However, fat also plays unique roles in the diet, including increasing the absorption of fat-soluble vitamins and contributing to the flavor and satisfaction of food. The functions of fats in the body: storing energy. The excess energy from the food we eat is incorporated into adipose tissue, or fatty tissue, Most of the energy required by the human body is provided by carbohydrates and lipids. As discussed in the carbohydrate unit, glucose is stored in the body as glycogen. While glycogen provides a ready source of energy, it is quite bulky with heavy water content, so the body cannot store much of it for long. Fats, on the other hand, can serve as a larger and more long-term energy reserve. Fats pack tightly together without water and store far greater amounts of energy in a reduced space. A fat gram is densely concentrated with energy containing more than double the amount of energy as a gram of carbohydrate. We draw on the energy stored in fat to help meet our basic energy needs when we're at rest and to fuel our muscles for movement throughout the day, from walking to class, playing with our kids, dancing through dinner prep, or powering through a shift at work. Historically, when humans relied on hunting and gathering wild foods or on the success of agricultural crops, having the ability to store energy as fat was vital to survival through lean times. Hunger remains a problem for people around the world, and being able to store energy when times are good can help them endure a period of food insecurity. In other cases, the energy stored in adipose tissue might allow a person to weather a long illness. Unlike other body cells that can store fat in limited supplies, fat cells are specialized for fat storage and are able to expand almost indefinitely in size. An overabundance of adipose tissue can be detrimental to your health, not only from mechanical stress on the body due to excess weight, but also from hormonal and metabolic changes. Obesity can increase the risk for many diseases, including type 2 diabetes, heart disease, stroke, kidney disease, and certain types of cancer. It can also interfere with reproduction, cognitive function, and mood. Thus, while some body fat is critical to our survival and good health, in large quantities it can be a deterrent to maintaining good health. Insulating and protecting. The average body fat for a man is 18 to 24%. For a woman is 25 to 31%. But adipose tissue can compromise a much larger percentage of body weight, depending on the degree of obesity of the individual. Some of this fat is stored within the abdominal cavity, called visceral fat, and some is stored just beneath the skin, called subcutaneous fat. Visceral fat protects vital organs such as the heart, kidneys, and liver. The blanket layer of subcutaneous fat insulates the body from extreme temperatures and helps keep the internal climate under control. It pads our hands and buttocks and prevents friction, as these areas frequently come in contact with hard surfaces. It also gives the body the extra padding required when engaging in physically demanding activities such as ice skating, horseback riding, or snowboarding. Regulating and signaling. Fats help the body to produce and regulate hormones. For example, adipose tissue secretes the hormone leptin, which signals the body's energy status and helps to regulate appetite. Fat is also required for reproductive health. A woman who lacks adequate amounts may stop menstruating and be unable to conceive until her body can store more energy as fat. Omega-3 and omega-6 essential fatty acids help regulate cholesterol and blood clotting and control inflammation in the joints, tissues, and bloodstream. Fats also play important functional roles in sustaining nerve impulse transmission, memory storage, and tissue structure. Lipids are especially focal to brain activity in structure and in function, helping to form nerve cell membranes, insulate neurons, and facilitate the signaling of electrical impulses throughout the brain.